Okay, so now we're moving on to one of the main items in the lecture. This is the ratio test. So let some an be a series, so any series, positive or negative terms, and we define L to be the limit as n goes to infinity of the absolute value of an plus 1 over an. So L is the limit of absolute value of the ratio of successive terms. So an plus 1 over an. So if L is less than 1, then the series converges absolutely. And hence by the theorem, and hence converges. 2, if L is greater than 1, then the series diverges. Third point, if L equals 1, then the test is inconclusive. So if L equals 1, the ratio test tells you nothing. You don't know if you have divergence or convergence. So, what's the intuition behind this? Intuition. So if L is this limit of an plus 1 over an in absolute value, this would tell us that the absolute value of an plus 1 is roughly equal to L times the absolute value of an, as n gets very large. So this starts to look like, if you want to go from an plus 1 to an, you multiply by L. So it starts to look like a geometric series with multiplier L. That is the absolute values of the terms. So if you were to take the sum of the absolute values of the ANs, as n gets very large, it starts to look like a geometric series with multiplier L. So then if you go through the points, this almost looks like the requirement we had. If the absolute value of R was less than 1, we had convergence. If it was greater than 1, we had divergence. Okay, so that's the motivation for the ratio test.